All right, today we are going to look about testing a claim about a mean, but it's going to be different because we're going to have what we are calling paired data. So when we have paired data, a lot of times in studies, it's more convincing to compare things than it is to just have a single sample investigation like what we've looked at so far for the means. So a lot of times they will take one population and get two pieces of information from it. For example, maybe like, does a diet work? And you'd have a before weight and after the diet weight. So you would then be comparing those. So you would have two observations on the same individual. Sometimes you have one observation on two similar individuals, like on twins or something, but usually it is two observations on the same individual. So I only have one population, I'm getting two pieces of information. So we call this paired data when we look at it. So it's going to be measuring a quantitative variable twice. Again, like I said, before and after, like on a diet is a really good one to look at. So when we look at this, we're going to use our same one sample T procedures that we learned in section 11.1 last class. But this time, instead of just a mean, notice here it's a mean diff or mean difference. So when we look through this, they often will call these methods paired T procedures. So just like we had before when we were doing our test for the mean, you have to have all of your same conditions. So we have to have it to be random. So our data has to come from a random sample, or it could be from a randomized experiment. It has to be normal. So we either know it's normal, our population's bigger than 30, or remember, you're going to have to graph it. If you have to graph it, you need to show the graph. And then our 10% rule still holds. So when we are doing our significance test for the difference between this and what we did on Monday in section 11.1 is that here our hypothesis is not just going to be the mean, it's going to be the mean with the DIFF with it, so that we know it's of a difference, not just a mean of our hypothesis value. Well, this value is going to be easy for us. It's always going to be 0. So when we have a paired data, this will be our null hypothesis every single time. It will always be 0. And then, of course, our alternative would just be less than, greater than, or not equal to 0, depending on what we're looking at. So when we do it, we have our test statistic again. Okay, so this would be our test statistic. The reason it has difference is you're going to have to find the data. You're going to be given two pieces of information. You're going to have to subtract them to get the information. You can still use the t-test, just like we did in section 11.1, on your calculator and get all the pieces of information, which we'll look at. So we're going to do one example here because it's very similar to what we did on Monday at section 11.1. Here we have researchers designed an experiment to study the effects of caffeine withdrawal. They had 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, or other substance of caffeine for the duration of the experiment. So during a 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took a placebo. So could have a placebo, could have caffeine. The order in which the subjects took the caffeine and placebo was randomized, so there's our randomization that we need. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. So the table below, missing my T here, the table below displays data on the subjects' depression test scores. Higher scores show more depression. So we had 11 subjects, you can see on our first line, and then we have our data with the caffeine pill and our data with our depression pill. So what we have to do is we have to find our new data, which we're going to do on our next little slide right here. But first, let's set up our hypothesis. Remember, the first thing we need to do is state like it always is. So when we state, remember I said our hypothesis will always be mu diff equals 0, because back here it said it wanted to know if it was, whoops, where'd it go? Withdrawal increases. So if it's increasing, that's where our greater than 0 comes from. We need to define our parameter. What does mu diff stand for? It's the true mean difference. This has to be given. What order are you subtracting in? The order you subtract in makes a difference on what goes into this alternative. Because I want withdrawal to increase depression, that means I want placebo to be bigger than caffeine, which is my greater. So if you did caffeine minus placebo, that changes this to a less than sign. Doesn't make your test wrong, but I need to know which way your subtraction is working in depression test scores for subjects. Then this also tells you how to find your data. I'm doing placebo minus caffeine. So to get our data that we need to use in our calculator up here, we have to subtract these two pieces of information. I want placebo, which is my bottom one, minus my caffeine. So in this case, it's going to be 16 minus 5, so this one would be 11. 23 minus 5, 18. All the way down, 5 minus 4. We can keep on going here. So we're subtracting all these values. Okay, it is possible 0 minus 1 is a negative number. That's fine. This is the data that we're going to use to make this test. So from here, once we have our data and we know what we're doing, this is the information that needs to go into your calculator, into your data. Don't find the mean and all that. We'll just use our calculators to get our answer. So first thing before you move on, maybe pause this and put this information into a list L1 in your data so that you can follow along with the calculator and what we are going to do. So our next part is to plan. So remember, when we plan, we are going to do our paired t-test, which really just means it's also just a t-test in our calculator. It's random. It told us in there that it randomly assigned the treatments. Told us, so since it was random, we're good. Normal, large, we would not know. We would have to put that data when I did the subtraction. So the 11, the 18, the 1, all that, you need to graph it. I have a histogram over here. You can make the graph whatever you want. Most of you are using box plots, so make sure you can get a box plot. It doesn't show any outliers or any strong skewness, so we're good. And then for some reason, my 10% rule did not show up in here, but we can do for independent, not sure where that went. We can say that 11 is less than 10% of all of our subjects. Can't remember what it was looking at. Well, they just said volunteers and caffeine, so we'll just say of all subjects. Also, you can just think about it. Each person is independent of each other, so we know we have independence. When we're doing an experiment, independence is just implied. So you wouldn't have to state this. You wouldn't have to do this part. You could say it's just there. So then we have our do part. So our do part, this is going to be our t-test in our calculator, and you're inputting the data. Okay. So when you run your t-test, go through and hit everything that we did from Monday, you should be able to see the mean of your data was this, your standard deviation was this. We know our degrees of freedom. It also gives you your test statistic, so you should see your test statistic of 3.53. Using your tables, which none of us are going to be doing, but if you were using your tables, remember you can only give me a range, but then your calculator gives you your p-value of 0.0027. So it gives us all our information that we need to write down. Everything that's circled, we should be writing on our paper so we know what it is. And then you have to make your decision. So it didn't give us a level of significance. So remember, when it doesn't give us a level of significance, that means we're going to use 0.05. So when it gives us our 0.05, we need to compare these two values, 0.0027 and 0.05. My p-value is less, so that means we reject, so we make our conclusion. Since our p-value is less than alpha, we reject our null hypothesis. Remember, we have to have this whole sentence. Therefore, we have convincing evidence that caffeine withdrawal increases depression test score on average for subjects like the ones in this experiment. So there's our conclusion statement. So you can pause and get that written down. So the test is just like what we were using last time. The only new thing you have to do today is that you have to subtract your data, right? Subtract what's given to you to make a new list that you put into your calculator, and then run the exact same test that we had last time. Okay, any questions, let me know. I'll be back next week. We'll review a little bit and talk about it and move on to our next test. Have a great day.